Alright, in chapter 6, we're going to look at systems of equations and different ways to solve them. When we're talking about a system of equations, we're just talking about more than one. In Algebra 1, so in this class, we're only going to look at 2 equations at a time, but you could do a system of 3, 4, 17 equations, however many you wanted to do, as you get up into higher math. So we are going to solve systems of equations. And the solution to a system is always going to be an ordered pair. So it's the x and y value that makes both equations true, because we're looking at 2 different equations. So we've talked about before when we just have one equation. So if I just look at this blue line, every point on this line is something that makes the blue equation true. So the blue equation is true here and here and here and here and everywhere on that blue line. And then the same thing is true for the red line, here and here and here and here. Those are all ordered pairs that would make the red line true. But when we have a system, we want one point that will make both of them true. And the only point that is on both lines is right there. So wherever the 2 lines cross, that ordered pair is the solution to the system. Okay? So here we have 2 lines that cross and they have one solution, the ordered pair, where they actually touch each other. You could also have a case of infinite solutions if the 2 lines are exactly the same. So if you solve for y and get 2 equations that are the same, the lines would be right on top of each other and they would have infinite solutions. We could also have a situation like this where we have, remember, these are called parallel lines, and they'll never touch each other, so they have no solution. Right? So for 6.1, we are going to look at solving equations by graphing. Alright, so here is the first example. We have y equals negative 2x plus 4 and y equals x minus 5. So I'm going to start with this one, and I'm going to do them in 2 different colors. If you want to grab some highlighters or colored pencils and do that in your notes as well, that might be a good idea. So I have negative 2x plus 4. I'm going to graph the y-intercept first, 1, 2, 3, 4, and then my slope is negative 2 over 1. Down 2 over 1. Down 2 over 1. I can keep going for a long while. Down 2 over 1. Okay, and then you will have a straight edge, so your lines will be perfect. I'm going to do the best I can. Alright, and then I'm going to do the second line in blue. So now I have x minus 5. So minus 5 is my y-intercept, and then the slope, there's no number there, so I know it's 1. Alright, so up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and then I draw my line. Alright, and again, the solution is the point where they cross. So right here, those 2 lines cross each other. Alright, so my solution is going to be 1, 2, 3, negative 2. So 3, negative 2. That is the solution because it's the only point that is on both of these lines. Alright, and you're always going to check your work, and you're going to check by taking this ordered pair and plugging it into both equations. So I'm going to do the red line first. I would have negative 2 is equal to negative 2 times 3 plus 4, because I plugged the x and y values into that equation. Then when I do the math, negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. Negative 2 is equal to negative 2. That is a true statement. I have to do the same thing for the blue line, so y, negative 2 equals x, 3 minus 5. Alright, negative 2 is equal to 3 minus 5, which is negative 2. So again, I got a true statement for both equations, so that means that 3, negative 2 is the solution to this system. Alright, now here's the second example. So I have 1/2 x minus 2. So I have negative 2 as my y-intercept, and then I'm going to go up 1 over 2, up 1 over 2, and draw my line. Then the second equation in the system is also 1/2 x minus 2. So it's the exact same line. So they are right on top of each other. Alright, which means that every single point on the line is a solution for both equations. So I say this has infinite solutions. Alright, wouldn't matter what point I plugged in, it's going to make, if it makes this equation true, it's also going to make the second one true. There is a third example. I'm doing the same thing. I'm going to graph them and find where they cross. So first equation, negative 2x minus 5. So I have negative 5, and then if I were to go down to right 1, I would be off the grid. So remember, we can reverse it. I can do down to right 1, or I can do up to left 1, which is what I'm going to do here. So up to left 1, up to left 1. Alright, up to left 1. And then I have my line. Okay, then I'm going to do the second line in blue, so negative 2x plus 3, so up 3. And I'm going to go down to right 1, down to right 1, down to right 1. Alright. Now, what we have here, alright, remember we did this back in chapter 4, alright, they have the same slope and a different y-intercept, so those are parallel lines. Well, one thing we know about parallel lines is they will never cross each other. If they never cross, then there's no solution, because the only time I can have a solution is when the lines cross each other. Alright, here we have example 4. So again, I'm going to graph both of these lines. So if I start with this one, y equals x minus 2, I have a y-intercept of negative 2 and a slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1. Alright, there is my first equation. Now this second equation is not ready to be graphed yet, because I can only graph things when they're solved for y. So I have to actually get y by itself here. So remember, 2 steps. First step is move the x, so I'm going to subtract 2x from both sides. Now I have 3y equals negative 2x plus 9. Step 1, move the x. Step 2 is divide. So I divide by 3, divide by 3, divide by 3. Y is going to be equal to negative 2/3 x and then plus 3. So now I'm going to graph this. I go up 3, and then I'm going to go down to right 3. Down to right 3. Alright, and draw that line. Okay, then my solution is where they cross. So right here, that order pair is 1, 2, 3, 1. So 3, 1 is the solution. Alright, I'm going to check my answer by plugging 3 in for x and 1 in for y in both equations. So if I do that, for the red one, I get 1 equals 3 minus 2. Well, 3 minus 2 is 1, so that's a true statement. Then if I try the blue one, I'm going to go in the original. Okay, so I have 3 times 1 plus 2 times 3 equals 9. Well, 3 times 1 is 3. 2 times 3 is 6, and 3 plus 6 does equal 9, so that is true. So we can always check by plugging back in. I'm going to have you do that every time, but I'm also going to show you how you can check your solutions and solve by graphing on the calculator. So go ahead and get your calculator out if you don't have it sitting next to you. Okay, I'm going to go through the keys on a Casio first. So if you have a TI, you might want to just fast forward on the video until you see your calculator pop up on the screen. The directions for these are on that calculator sheet that I gave you. If you've lost yours, you should go to SchoolFusion and print another one. Alright, so I need graphs, so I'm going to go to the menu and go to the option for graphs. So on my calculator, it's number 5. Alright, and then I'm going to type in both equations. So here's my first one, it's x minus 2. Alright, and then my second one, I'm going to type it in solve for y, so negative 2/3, I'm going to use the fraction button, x, plus 3. Alright, so I have them both graphed, and then I'm going to pick F6 for draw. So then the calculator draws both of them for me, and I don't have to try and guess and count and see where they cross each other. It will actually do it for you. If you notice on above F5 it says G-solve. That gives you all of the options of the things the calculator will do for you. Okay, so roots, max, min, y-intercept, and this option right here, ISCT, stands for intersect. And that's what we want. We want to know where the lines intersect or cross each other. So if I press F5, and then it calculates where they cross, and it says it's at 3, 1, and that is the answer that we got as well. So your calculator can also find the places where the lines cross. Alright, so Casio people, I want you to do the next example, number 5. Make sure you have that done and we'll go over the answer in class. And now I'm going to go through how to find the intersection on a TI. Alright, so the directions for the intersection on TI are on that calculator sheet that I gave you a while ago. If you have lost that, you need to go to SchoolFusion and print another one because that's going to be very helpful to you. So, I need to graph both of these lines. And remember, graphing things, we go to y equals, and then I'm going to type in the equation. So my first one is x minus 2. Oops, I need minus. X minus 2. And then the second one is going to be negative 2/3. So I got to do division in parentheses. Negative 2/3 x plus 3. So I have my two equations typed in. I'm going to go to the graph. Alright, and it's going to graph both of those lines. Alright, and your screen is so small, I don't want you to try and count and figure out where they cross. Your calculator will actually do it for you. See right here where it says calc in blue? That's where you're going to get all the options. So to get to the blue, I have to press second, calc, and here's all the different things that the calculator will find for me. I want to go to number 5, the intersection, alright, the place where the two lines cross. That's my solution. So I'm going to pick number 5. Your calculator is going to ask you some questions. First curve. It just means which line do you want to use. It doesn't matter which one is first. Just press enter. Same thing. As long as it goes to the second one and gives you your second different equation here, just press enter. Then the calculator asks you to guess. I don't want to guess. I just want to know what the answer is, so press enter again. So basically you're just pressing enter 3 times, and then it tells you the intersection is 3, 1, just like we got when we graphed it ourselves. Alright, so you're going to do example number 5, draw your graphs in your notes, then check your answer with your calculator, and we will go over it in class when you come. That is it for 3-1 solving by graphing. See you guys in class.